where somebody else takes you out of the frame and put your name to shame, cover up your face. You can't run the race, the pace is too fast, it just won't last.
All right, welcome to lecture 26, we'll call it, for April 23rd, 2020. If you didn't catch it, that is Points of Authority from Linkin Park, and that is actually going to be like one of the best song tie-ins of the entire, not just the semester, but the entire year. You'll see at the end. All right, let's get to it. So today we're talking about valence bond theory, and this is sort of the formal way that we describe exactly how electrons are shared and how they're actually physically placed in a way that holds nuclei together, which is how we've been talking about bonding the whole time. What's really new is now that we're going to, hopefully I'm going to bring up a possible problem with what we know before about electron shapes and orientations. And the shapes that I told you molecules takes with via CPR last time, and then reconcile them. So since we're going to talk about reconciliation with VSEPR, let's review it. So we use balloons to talk about the shapes that maximize the distance between a certain number of mutually repulsive items tethered to a common center point. And for two electron domains, that was a linear geometry. For 3 electron domains, it's trigonal planar. For 4 domains, it's tetrahedral. For 5, it's trigonal bipyramidal. And for 6, it is octahedral. All right. So what is valence bond theory? Well, it's sort of this, that basically for electrons to be shared, the idea simply is that they have to be close enough to the second nucleus. So let's talk about this 1s electron in this hydrogen atom right here. That if these atoms get close enough, and the nuclei would be like right in the middle right here. If these get close enough, let's say like this orientation here, that this electron has significant electrostatic interactions with its own original nuclei and the nuclei of the other atom. Now, this is an electrostatic attraction, or interaction, I should say, so it's distance dependence. And when they're this far apart, you don't get much of it. When they're this far apart, there's a significant amount of it. If they get closer than that, then the repulsion from the two nuclei are sufficiently big that the electrons can't cancel it out. And that's bonding. They're just, the nuclei are physically close enough that the electrons can sort of glue them together, or glue the nuclei together, but not too close that the protons just really repel each other too much. Now, different types of electrons can overlap and interact with their neighboring atoms. So this example right here is sort of one way of describing the single bond. So if I were to ask you to do the Lewis structure for hydrogen fluoride, you would hopefully give me something that looks like this. We've got 3 unshared pairs on the fluorine, the single bond, and that's it, because that's really all that hydrogen does. And what is the nature of this bond right here? Well, it's just the 1s electron and one of the 2p electrons from fluorine, that the atoms are arranged in such a way that that 1s electron is interacting significantly with the fluorine nucleus as well as the hydrogen, and the same goes for that 2p electron. It's interacting with the fluorine atom as well as the hydrogen atom. And for F2, that Lewis structure, hopefully, you would give me something that looks like this. And again, so what's the nature of that single bond in the middle there? Well, in this case, we would say that it's actually a 2p electron from fluorine interacting with the one fluorine nucleus and the other. And same goes for this other member of this pair. This electron is lined up in a way that it can interact significantly with the original fluorine and the other fluorine atom. So you can talk about having overlap and interchange of the same types of electrons and different types of electrons. But that, in a nutshell, is valence bond theory. And in the next video, we'll actually put together a 3-atom molecule, and this is where perhaps complications arise. See you there.